Hello and welcome back to our series going through the GCSE Physics spec. Today we're going to be looking at some past paper questions. These are all questions that are based on the lessons we've done so far. So if you've not checked out the rest of the series, make sure you do that. Make sure you practice each of those lessons and then come back to this one. Like always, this is available to download, links down in the description, or if you are one of my students, this is on Google Classroom along with this video. Now, question number one, figure 7 is a velocity time graph showing 34-second part of a train's journey. So we've got this velocity time graph, just here. Now the question, calculate the acceleration of the train in the 34 seconds. Give your answer to an appropriate number of significant figures. So we are asked to calculate an acceleration. So we need to think about the equation that we need. And we know the equation, acceleration equals a change in velocity over time. If you're not sure about that equation, check out the video about calculating acceleration. I'll put it in the top corner. Now we need to find all of our numbers. So A, we don't know. V. Now remember, V is our final velocity. Okay, we'll be able to find that from the graph. U is our starting. Once again, we'll be able to find that from the graph. And T is the time. Now we're going to look at the full 34 seconds. We already know T is 34. Now let's look at our starting velocity, that U. Got that here. Now we look at the scale. See 10 and 15. So we know each little square is 1. So we've got 11, 12, 13, 14. Okay, so it's 14 meters per second. So fill that in. That's our starting, 14 meters per second. And then our final is over here. So this is 25. That must be 26. So that is 26 meters per second. And now we can put those into our equation. So remember, we've got our formula, find our variables, and now we're doing substitution. So A equals 26 minus 14 divided by 34. And A equals, if we do that on the calculator, 26 minus 14 divided by 34 equals 0.35294 onwards. Now we're asked to put this to an appropriate significant figures. Now if we look, every number we have is two numbers. Okay, 26, 14, 34. So I would always say an appropriate number of significant figures is 2 decimal places. So you put this to 2 decimal places, we have 0.35, and our unit is there, meters per second squared. Perfect. Now, we're going to calculate the distance the train travels in that 34 seconds. Now, to calculate distance on a velocity time graph, remember, distance equals the area under the line. It's always good to write that sentence because you will actually get a mark in some exams for showing that you're trying to find area. Now, let's go up here. Okay, and we can separate this out into 2 shapes. We've got this triangle. Okay, this shape here. And then we'll do a different color. We then have this rectangle as well. So the total distance is adding these 2 shapes together. So the area of the triangle plus the area of the rectangle. Let's start with the rectangle. So we know it has a base of 34 and it has a height of, let's move that out of the way, of 14. So we're going to do 34 times 14 gives us 476 meters. Now I know that's meters because if I look here, each of these squares, if I take one of these little squares, okay, has a length of 1 second and a height of 1 meter per second. Okay, so if we did 1 times 1, obviously equals 1 meter, which means each box equals 1 meter. So when I find this area for every box, every little box, that's 1 meter. So there's 476 boxes, basically, is what I worked out. So 476 meters. Now, if we look at the triangle, remember, area of a triangle like this is half times base times height. So the base, once again, is also 34. And now the height is 14 to 26. So that's a height of 12. Okay. Do that on a calculator just to double check. Perfect, 12. So that is going to be that area equals half times 34 times 12. So the area equals times 12, 204 meters. So the total distance is adding those two numbers together. So total distance is 204 plus, was it 476? 4 plus 476 equals 680 meters. 680 meters. Perfect. The unit's already there for us. So that's the first question. So that's November 2021. That was actually question 4B in that paper. So if you look at that full paper, that's where you would find this question. Hopefully that makes sense, and we'll move on to the next question. Okay, let's carry on where we just left off with question number 2. So figure 5 is a velocity time graph for a lift moving upwards in a tall building. So you can see the lift here. And one thing to think about whenever you come across a new graph or a new diagram in an exam is try and think about the story that it's showing you. So in this case, we're talking about a lift. So we can see, and I'll rub this out afterwards, but we've got an acceleration here because we've got an upwards gradient. And then we've got a constant here. Now, a lot of people would look at this and think that the lift stopped. But remember, this is a velocity time graph, which means this is a constant velocity. So it's accelerated up, it's a constant velocity, decelerates, and then here, this line is where it stops. So this is where it stops at whatever floor, and then it accelerates again, gets that constant velocity, and then decelerates, okay? And one thing with this graph as well is we've got positive velocity and negative velocity. So that must be that lift, and we assume when it's going upwards, and it does say moving up. So when it's going upwards, that's positive velocity. And then when it moves down, that's negative. So this whole journey, we can assume that that lift is going up the building. So use the graph in figure 5 to determine the acceleration of the lift for the first 1.4 seconds. This is very similar to what we just did in the previous question. We always write our equation, and then we find each variable. We want to find the acceleration. We've got v, u, and t. So the final velocity, the v, is 4. So we're going to 1.4 seconds. So that is here. So it's 4 meters per second. It started at 0 meters per second, and it took 1.4 seconds. So you put those numbers in, 4 minus 0 divided by 1.4. So A equals 4 minus 0 divided by 1.4. That is 2.857, blah, 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 blah. An appropriate number of figures, once again, we go 2 decimal places, 2.86. Just check the unit is there, meters per second squared. Right, into our final questions. Question number 3. A car driver sees a rabbit on the road. The driver makes an emergency stop after he sees the rabbit. Figure 6 shows the speed of the car from the time the driver sees the rabbit until the car stops. So we've got speed time graph, okay, right here. Distance the car travels in the first 0.5 seconds. So remember, distance equals area under the line. Okay, so we want to find this shape here. So we've got 0.5 width, we've got a height of 16. So 0.5 times 16. Now I know a lot of you can do that in your head, but I would always recommend just use a calculator, double check, make sure. So you got 8 meters. Perfect. And that was from a sample paper in 2016. Okay. Now you'll notice all 3 of those questions are actually about velocity or speed time graphs, and that's because they are the most common, because of those questions on finding distance, finding acceleration. They're getting you to read from a graph, getting you to interpret a graph. So that's the higher level stuff. Now, that doesn't mean that they won't ask you about distance time graphs. Obviously, you need to practice all of it, but velocity time graphs are normally the ones that people do find a bit more challenging. If you want to have some practice of distance time graphs, let me know in the comments, and I will also make a video on some distance time graph questions as well.